talk about impressions of this Down syndrome article a little bit. And then look at R&R Studio. Like a little more information, particularly for people using Mac computers. And then look at just another example of using R, describing data, kind of understanding the mix of what commands you have to type, what's already been done, and so on. All right, so I handed out this article on related to research on Down syndrome. This is an American Scientist magazine. American Scientist is a publication from an organization called Sigma Scientific Research Society, and they're often summary articles or popular articles intended for a general scientific audience with some technical details, but not a lot, right? And so this one's about research that's been done on Down syndrome and things like that. Right? So I find the article interesting because it kind of describes how different pieces of evidence and different studies have kind of come together. Right? And so how did people decide what's a difference that they noticed between people with Down syndrome and people who do not have Down syndrome that's important for this article? Or what impressions do you have about the research that went into trying to have an understanding of what's going on? Yes?
People with Down syndrome have an extra chromosome.
Mm-hmm. So that's part of the definition. They have this extra chromosome. What do they see as a result of this extra chromosome? There are some changes.
It's like an increased immunity with certain cancers.
Yeah, so they started to notice that there's some differences in the rates of cancers. Right? Some occur less, some occur more. Who do you think initially saw this? Families of individuals, doctors who specialize. Right? Hey, we're not seeing many cases of this, but I know in the other areas that this is a common disease. Or wow, we have all these celiac disease and other autoimmune disease. And so there's probably some case studies and anecdotes, right, that probably came first. Like, there appears to be a difference. Is this something just my patients, or is this more broadly? Right? How would they conclude, what type of evidence would they use to conclude that it's not just their patients, but more of a difference between those with and without? They would need bigger information, right? They need some population information, right? Whether a health interview survey or just registries of certain specialized cancers. Within, there's something called the SEER registries, which is surveillance and end results system that records all cancers in certain areas of the country, certain states, certain metro regions have signed up. And so there's a repository of somebody's diagnosed with cancer. They're supposed to put their information in this so that they can track actual rates at a population level. Right? So they probably had that information on a population study, a very large group of individuals with Down syndrome, and saw, there is a difference, right? How about then proteins, right? I mentioned studying 4,000 proteins. There's a little detail in there that's kind of interesting to me, right, as a statistician, right, of how they did those studies, right? So it's into that paragraph that in the second column, right? The teams, they investigated levels of more than 4,000 proteins in blood samples from 263 people, 165 who had extra chromosome, and 98 who did not. And then it says matched for age and gender. Right? So this is not a randomized study. You can't randomize somebody to have Down syndrome in any way. Right? They did a match study. Why did they do matching?
Decrease the amount of variance in the study.
Yeah, so they decrease the amount of variance, right? So different proteins are higher for women, higher for men, right? They change by age. A lot of things change with puberty, but young adults, older adults, there's gradual changes all the time. Right? So they match. Right? There's some families would have one child with Down syndrome and one without. They could have matched based on siblings. Right? And then they would have got a lot of family history and genetics. They might have even matched more precisely to control variability more. Right? But it looks like there's a number of ones that are significant. Why are they interested in some of these chromosomes? some of the some protein levels. So there's some biological understanding, right? So they're working with lab scientists, human biologists, right? That know that some of these different proteins are involved in different processes, different immune responses, right? So it's kind of the statistical evidence, and then understanding the biological sciences more, right? So they kind of support each other. Here's these ones that seem to have elevated levels. Here's a bunch of them that we know are related to that, right? So it kind of goes together as kind of another level of evidence, right? And did anybody get as far as the second page when they're talking about clinical trials? Starting to do some clinical trials, right? So what could you possibly want to do a clinical trial about? Yeah.
Well, they were doing something about like inhibitors for certain proteins that were being made too much,
Yeah.
and they're doing trials to see if those would affect people with Down syndrome or just people with like rheumatoid arthritis.
Mhm. Yeah. So in other autoimmune diseases, sometimes they're able to lessen the impact of those by giving treatment that modify the levels of proteins and other things that are modifying the receptors and things like that. So maybe those would be beneficial for individuals with Down syndrome. So how do you establish evidence that would suggest that it would be a good treatment? You can do randomized experiments, right? Anything you alter or affect probably has some impact down the line or other things. So they're probably looking at the whole health of the whole person along with these things. But it could be a randomized experiment, right? Some individuals with Down syndrome could get a placebo, some could get a new drug, or maybe a couple versions of a drug. And if you get enough individuals involved and there really is some benefit, they might be able to prove it based on these studies. So I thought that this article is kind of interesting in that it brings together data, the understanding over the course of maybe 30 or 40 years must have come from a lot of different sources. And they use some statistical techniques like matching, randomized trials to take it to the next step, where within our lifetimes there might be treatments that mitigate some of the negative aspects of having an extra chromosome, right, biologically. And I thought they did a nice graph, the descriptive plots of showing how there's differences were pretty convincing that there's a real difference between those. And so, but any comments or thoughts about it? Kind of ties in with the description and with the study type and kind of the broader picture of how these things fit together. So. Anyway, I provide that just as an example of something that's kind of neat that they're getting that understanding of. So in terms of this RStudio and installing R, has anybody tried to put it on their computer? Yes. Are you using a PC or Mac or Mac? Okay. Did it work for you? No. Okay. So
I think I got it with a Mac.
you think I got it with a Mac? So the primarily I work in Windows, so my experience is primarily in this Windows. So again, this site is called CRAN. If you just search for CRAN in Google, this Comprehensive R Archive Network is usually the thing that comes up. And for Windows, but I wanted to install it on my Windows machines. I just clicked on Windows and this base distribution, click on download, then it downloaded a file. And then I clicked on that and opened up and walked it through, and that seems to be no problem doing that. The last time I had students install the Mac version was last semester, so September, and there might have been a change since then. So if you click on this Mac OS, it has a package here that you would download, but it has this extra little note in here that it says it needs this X11 program, right? So there was this graphic interface program that used to come with the with Macintosh. The X has nothing to do with it being Max 10. That Max 10, that X is the number 10, Roman numeral 10. This X is some type of graphical interface thing. So they're separate X's, so they're not really tied to each other. But it says it needs this program to be installed. So it's, I had a couple of students in my other class do this, that they went to this XQuart site that's listed there. Right? And there's this other thing called XQuart. It's going to get this X11 graphics thing onto the Mac. Right? So there's kind of two steps, right? for that is instead of just the one, get this graphics X11 thing, download it, you know, it'll show up in your downloads, and you click on it and it goes through and you do an installation of that. And then you go to get this package for yours, or if you're not at 10.11 on Mac, if you're on, like here, this one is 10.9 or 10.6, there's a couple older different versions that work for that. You just need one of these packages, download that, and click on it, and we'll start step you through it installing. So instead of just one, it looks like there's two to work. But I had a couple students have done this, and it seemed to work. So try that. RStudio, if you go to this RStudio website again, you can download that. Just the free desktop one is fine, and there's just a program for Mac or Windows or other stuff if you want that. So that seems to work. So a little setup. Once you get this set up and working, you should just do it once and not have to do it for the rest of the semester. And then you have this tool that you could use for this class or other data analysis. So, if you don't want to do all this right away, it's on some of the library computers and some other places. So you could go there and look at it for the purposes of doing the homework. But any questions about? If you're sitting here with your computer and want to try to do it now, you can kind of click through it and get it going and see if it will work for you. What I wanted to show you is a little bit of how you could do, approach the homework. Right? So there's these homework files on there. If you go to the assignments link, you can they're also linked in there. There's the statement of the problems, which is the PDF or Windows document file. There's this R data, which is all the data sets, or R script, which is all a bunch of R commands that you might do, and then some raw data sets. By raw, I mean those are the data outside of R that I did read in there. So with this or a lot of other programs, knowing where your files are on the computer helps you manage everything. You want to know where things are if you want to be able to open or modify or move stuff. So what I would recommend doing is creating a directory to store your stuff for R, for this class, right? So just under this, piece, this is one option when I open a window for this PC. If I go under the documents for that, I created a little folder called My R Stuff for Stat 140. Right-click. Oops, let me go back here. Right, so just right-click, create a new folder, and it creates a new folder, and then I renamed it as My R Stuff. Right? So I'm going to download the files and put them there, and then I'm going to start from there, and then I'll know where everything is. So if I save work, I save output, everything will be organized there. Right? And I know that I'm going to, I'll just start a Word document, right? And so my output for 140. Eventually I'm going to save a little bit of output there for the homework. If it can be short answer, like you just need the mean and median, you could just write those things on a piece of paper or type them into a piece of paper. Other things you can cut and paste from the program and put in there. So you don't necessarily have to show me your entire computing script. You don't need to print out every single graph and everything there. Right? You can do the computing, save bits and pieces, write it out in different ways, and answer the questions. Right? So from here, if I right-click, or wait, I can save that link as something. Right? And so it's trying to save this data set. Now, this is the new one I made here, so I'm going to save that data set. And I'm going to save this R script file. If I right-clicked it again, and it's downloading, so here's my R script file. And just so I have it, I'm going to download these other data sets, just because I'm here and it's fast to do. Oops. I didn't like that. Let's see CSV file. Let's see if this will come down. Saving, I don't want to save the link. Is that going to go? No, it doesn't. That's, this one will save it link as, it's making it. If I click on that thing, this is the data set. So let's see, how can that save as, no, it wants to do it as an HTML. I don't want it as an HTML. If I open it in a new tab, oh, no, let's get out of that. That one. The CSV ones were working fine. If I go to these files under homework and homework 2, here's this file, and then that one will save down and it's this text file. So 140, that's right. So we got those things in there, and so here, this is what's in this new directory. So if you take either the R data or this R script file, and I usually, when I put that name in there, R script, that's how I like to keep track of it, but it has that little R symbol on there. If I open it with a program, I can open it with RStudio, and then RStudio will open, and then it's synced into that directory, so it knows where everything is. So here, it opened this R script for me, a bunch of commands. Now I provided you with this R data set. So if you click on that, that's going to open up, and that'll have most of the data you need for the homework. So if I click on that, open it, yes, and now here's a bunch of variables that are in there. It's loaded that in. So a cholesterol, insect data, and a couple other versions, and there's a bunch of stuff in there that you can use. Right? So at this point, you have R going, you have your R script, which has a bunch of commands, and then you have the data that are in there. Now if you go through some of these commands, that should give you enough information to answer most of the questions. So once you go through this business of getting R and RStudio installed, right, then download the data into a directory and then open it in it, then you're ready to roll. So in future homeworks, when you already have the program installed and there's a new R script and a new data set one, you download those two things and you're pretty much, it won't take too long. It won't be much different each time through, so it's, if you get it to work this first time, it'll be the same pattern, hopefully. So in these, there's, if you look, there was, the first question asked about 6 people, right, in terms of, what was that, their, I can't remember even the number of days or something. And then it asked about 7. So this is one way of creating a vector of length 6. Right? So if I do this, I just put my cursor up there and click run, and it runs that line, or X7, it does that. And what this has done is just created, oops, I typed in the wrong place. Right? Click down here in the window and type X6. Right? And you get your 6 values that are there. And so things like typing the mean of X6 will give the average, median of X6. Right? There's a summary command that is not typed up there, but it gives a few more things there. Right? And then these are some of the numbers that would answer the mean and median and description of that. Now I didn't actually have to type X6 and X7 because to do this, because these were actually already there. If you look up here in this environment, it says which there's a history of commands and so on. If you're not seeing these things, you can look at that. When I started RScript, this was blank up here. There was no data up there. So if I remove X6, say, right, and then I try to look at X6, it just says it's not found. If it says it's not found, that means that the data doesn't exist in a place that it can see it. If I had skipped that one command, now if I do it, now X6 is there. X6 is listed up here, and that's my data set. So when it's like this, it's pretty easy to just read it. Right? Now this one is reading in a new data set. Right? That's reading it from an external file. The CSV files are one particularly easy way to read in because it's easy to do those commands. So where is that CSV file? Well, I see it over here in my file. So here's plots and packages and a few other things. But here's CSV, right? So that you can, that is my working directory. That's where, because I started from this area, so I should be able to see that. Now, this one, I'm going to make, let's call it a second copy of cholesterol. If I do, I'm going to copy and paste all that. If I had typed all that in there and then read it in, it's going to read in that data set and list it up here. Right? 24 observations, before, after, and a difference. In fact, I had done that before, so see, this is the command I used to read in the data into R. That's what it says. So you would not actually have to type that command again to get it in because the data is already there. But that's how I got it in. If you had your own data set in a CSV file and wanted to read it in, you could type something like that to bring it in there. But if it's already there, you don't have to necessarily retype it. And this one had one variable called difference. If I do the mean of difference or standard deviation of difference, these things give some output. So if you want those values, you can either write them down, right, on a piece of paper, or you can, copy this part. And if I go to my little Word, that's what I was doing before. In this one, I created, my output file, this little Word thing, and I can just paste it in there. Now you might want to edit it, if this is problem, 2A, and this is 2, this one is 2B. It's not, I'm not necessarily tying it to the homework, but as an example, you could annotate this, and then, write a little bit of description about what that is, and that would save the work. Now, alternatively, that wouldn't be too much, right? Even that stem and leaf plot, if you just put by hand on a piece of paper, that would be okay too. Every once in a while, there might be a page of graphs or something that would be good to print, but some way to record your output. If you do make some plots, like here's a block plot of this, these are the differences. It's possible to save a box plot like this. So under this export, you can copy that to a clipboard and copy the plot. Once it's copied, if you have a thing like this, right, you can just paste it in, and that's there. When I make handouts for you, sometimes I don't know why it uses all this white space. I could crop these things and get rid of that white space and make it a little bit. Say I want to make it a little bit bigger. I can make my plot a little bit bigger, but you wouldn't have to do that necessarily. But I do that to kind of save space and make it clearer. Right? Alternatively, if you didn't want to cut and paste this thing, right, this wouldn't be too hard to draw by hand. Kind of try to figure out what values are there approximately. And you could do a pretty good representation of that, and that would answer the question essentially. So again, you can cut and paste. For many things, you can just represent it on your paper after doing it. So, but it's not too bad to record your output a couple ways. Any questions? Any desire to have anything repeated? A few other commands. This is reading another data set. So this is the command I used to read in this valid data set about comparing a food frequency questionnaire and a dietary record. And it's there. The way we open things, it would see that data set. I save the data set. It should work. And I give it a new number so it doesn't overwrite anything. Oh, see, it read it in and said it was there. In fact, I had run that command, and the R data set that was on the website included it already, just to make it easy. So you can focus on really the summary. So you wouldn't necessarily have to read it in there if the data set is showing up over here. I mentioned that because sometimes students have wanted to repeat every command that's on there, right? And they want to read it in for themselves, but maybe it gets maybe on Max, it will add a character or do something funny. But I try to make it so that the data are there and you can answer the questions with fewer steps if possible. In any case, we attach this, the valid data set has a bunch of variable names in here. If I want to refer to those directly, I attach that there, and so that now R will know to look for those variable names. So you do summary of saturated fat, summary of saturated fat for dietary record, and then the question really asks you is to compare these summaries across these two ways of recording the diet information. Any questions about? Has anybody tried to download R while we're sitting here? Is that working? No, that's not working for yours, for
Mine
our
is not
Mac?
working either. It
Yours
won't
is-
let me like download the like X quartz thing either. It won't even like let me click on it.
It won't.
No.
I think mine worked. Mine worked.
Yeah. Yes.
I tried downloading my Mac and it wouldn't work, so I tried doing the Windows server that we get,
Yeah.
and I tried working on it last night. I can't find any of the information
Okay. Any of that there.
today. No.
So it seems to be working with some versions of Macs, but not others, or maybe not working with some. So if it's on a Mac, it's going to need the Mac download. It should be designed, and in my experience, typically puts an indicator on here for RStudio or R. If that doesn't show up for some reason it just skips making that, or your computer is set to kind of disable those additions unless you specifically ask for them. If you search on your Windows, like type in R, here it finds RStudio as a desktop application. So something typed under search, you can find that. So R is just plain old R. I don't know, but RStudio would start there, and then that should pull in R. They're supposed to be linked. So it seems to work with some, pretty consistently with Windows, with some forms of Macs. And for this first one, if to do the homework, if you would go to the library or someplace and use the one that's installed there, you could get the homework done. Now we want to try to figure this out so that it's more convenient. And probably I'll need to kind of look at individual cases to see if this is to make it work out. But anyway, whatever software we use for a class like this, there's almost always some issues. It's even if we use Excel, different computers here at St. Michael's have different versions of Excel with different add-on packages on them. And so in Stat 120 or things where we try to do just data manipulation, we find that what works on one doesn't necessarily work on the other, and it's a modern challenge of computing. Right? It'd be nice to use this software and get the full benefit of it, and after we get over this initial part, hopefully we are in the clear. So sorry it's frustrating for those who have tried, but it didn't work out. Hopefully we can find a way to make it work better. What I wanted to do with continuing on this in some description is look again at one process of downloading some more data, uploading it, and looking at some graphs. So we do a little bit with the content of the statistics and see how it works. So in the lecture files that are posted today, so there's in the lectures, in this one, the 7th, there are some different data sets that are in there. And I could download those, but a quicker way would, I'll just download the data set that have all this stuff in there to my, so that's going to go down there for a bunch of data sets. And this R script down there, and then take a look at some of these things, right, as examples. So under R, right, let's start it again. I'm going to get out of this one. I'm not going to save anything here. Right. Let's start on this new one here. So again, I have R installed in the RStudio. I made this directory, and so I know where my stuff is. And I'm going to open this thing with the RStudio apps, and it will give me that set of commands up there. Right. So we've installed our Studio, made a directory, downloaded those things, and now I've opened that. So right now it says I have no data because that environment is empty. Right? But I have this one over here. Let's see. If I look at the files, it was on plot, so that looked empty. But if I go on files, this is where I was coming from. Right? And so the selection 7 R data, if I click on that, do I want to load that? Sure. And now I get a bunch of data sets that are in there. So the first example is from a book called Statistical Sleuth that we use for a more advanced course. But the basic question in this data set is, does dropping silver iodide onto clouds increase the amount of rainfall? Right? So there was a randomized experiment where they had some days where it was suitable for clouding, for seeding the clouds. There's some cloud cover, there's some moisture up there. They just want to push it up a little bit more so that it actually rains. So they had 26 days which were suitable for that, and 26 days that were not, that were seeded, and 26 that were not. Right? And so there's these different versions of data that are there. I have not downloaded all of those, right? But for instance, if I had taken this one of this CSV file, right, and right-click and download, where'd it go? There it is, and put that in there. Then that data would have been in there. Here's that. There it is. This little file, this comma file, has a column for rainfall, a column for treated, untreated, unseeded, unseeded, and then some numbers here, right, of days. A little Excel file. So that little Excel file getting into R is this command, reading a CSV file in there. There's a way to once you get installed, you can import data sets and read things in. And I don't want to update a package on this one. It's on the system computers like this class one that's restricted. I have to do a little workaround. But on yours, that wouldn't apply, and it doesn't apply to my personal computer. But this little command will read it in, and that one, it finds it over here and reads it in. And you see it up here. So here's this data set, 52 observations, 3 variables. Right? The top of the data set, the first 6 rows are rainfall and unseeded there. The lower rows are there. Right? And to refer to some of these things, I might want to attach. So it's easier to refer to those, right? So, what question do we want to answer? Does the seeding affect rainfall, right? So how many were treated? 26 and 26, which is what the problem described for us. Let's see, let me zoom in just a bit. Let me know if it's generally too small, right? One way of making a box plot that splits it by different groups is this little tilde syntax in there. And here's a box plot. I can actually make this a little bit bigger, right, by minimizing that one window, maximizing this one. Right? So how does it look? Does the cloud seeding seem to have been effective? It's kind of compressed, right? That there's not much rain. Cubic inches of rain on some days, but other days it's much higher. But that median certainly seems to be pulled out, right? The third quartile seems to be higher. the big outliers seem to be big. Some unseeded days got fairly substantial rain, but most of the distribution looks like it's pulled up, right? So that was more rain with the cloud seeding. One thing you can do in R is select a subset of the rows. Right? So if the variable treatment is seeded, now things are case specific, whether it's uppercase or lowercase. Right? That provides a lot of flexibility, but you do have to type capitals and lowercase as it says. Right? But this part here, this treatment equals seeded, will give us a true or false. Right? It's like the double equals means like asking a question. If that variable treated is seeded, it will be yes. And then I'm going to take the variable rainfall, and that square brackets means select a subset of things. So for instance, if I do rainfall and I want the first 5 observations, or 6, right, here's the first 6 observations. The 9th observation, if I just put a 9 in there, it's going to be the 9th observation in there. Or the 9th to the 12th, if I'm interested in that. You can take subsets. It also can take subsets with this little logical thing in here. And so for a lot of this initial work, when it's comparing groups or taking subsets, I'll help with some of these commands. Right? So the thing it can do is you can do a summary of rainfall for the seeded ones, a summary of rainfall for the unseeded ones, right? And get these statistics. Let me even zoom in one more. Right? How does it look? For those, right? Which statistics are showing us that there's more rainfall in the seeded clouds? Yes?
The median's a lot higher than the seeded clouds.
Yeah, the median's 5 times as high, basically. Yeah?
And the mean is much higher.
And the mean's much higher, right? Those, yes.
The quadrats are a lot higher.
Yeah, the quantiles, quadrats, right? So the 24 versus 98, the first quartiles, the third quartiles are higher. So all those distribution points are up, right? Out of that. The maximum is higher, but you could, I think you'd still consider it to be Ray. If this one happened to have one, superstorm at 3,000, the maximum could be bigger in this one. But that'd be one storm out of the 26, and you still would have those other statistics to suggest that it's higher in the seeded group. Yep, right out of that. Histograms. Here's a histogram of the rainfall for the seeded ones. Here's a histogram of the rainfall for the unseeded ones. If you were interested in looking at that. Right? Now the rainfall's pretty skewed, right, to the right. With a bunch of smaller values and then bigger ones, right? Here's the first 10 values for rainfall, right? A few enormous values and others that are much more moderate, right? Sometimes we'll take transformations of these. So take the log of rainfall and just the first 10 observations. These are the things on the log scale. Right? Now, if you take a histogram of those after taking the logs, you get different pictures. Right? The histogram of logs is much more symmetric, right? Much more bell-shaped. And then also for the unseeded, right, is much less. This little X limits is one plot went from 0 to 8, one went from 0 to 9. So you can control the limits there to make it a little bit better. So transformations in a lot of other biological activities often are useful. ALR is an applied linear regression book that it's a kind of a companion book to the Math Statistics 351. And in that book, there's one data set provided that gives average body weight and brain weight for different mammals. Right? What's the relationship between body weight and brain weight? Are they generally getting bigger together? So there's a data set that's brains, and this data set, if I look at this environment, these things are already entered in there. There's a brain weight and body weight. So I'm not going to read them in again. And just to make it easy, I'm going to attach that. I said that there was an X and these other things, but that's not going to, right? So here is brain weights of these different mammals. Let's look at the data actually. If we just look at B1, these, right? So here's the data. Here's the different mammals, brain weight, body weight, grams, kilograms, different measurements, right? So what does a histogram look like? Let me make this bigger. Most mammals are not so big, right? There's a few mammals that are really big. What are those mammals that are really big, do you think?
Elephants.
Elephants, could be hippopotamus, giraffe, and so on, right? So some of these big ones. Asian elephant, horse is pretty big, right? Human African elephant, and so on. If we take the log of the brain weight for something that is skewed like that, it ends up looking like this. Because that exponential scale, a pretty big jump like occurs. Looks much more like that. And body weight, same story, even though there's a few individuals. Now, what's the relationship? We'll do more with these scatter plots in relationship between variables later in the course, but let's look. This is kind of fun to look at. Here's body weight and brain weight. Mostly, it's an increasing relationship. It's a little nonlinear here. Right? There's kind of some kind of curvature to it. Well, it turns out if you take the log of both of these things, there's some type of linear relationship on the log scale. It turns out there's a multiplicative relationship, like a percent basis. Right? For a lot of mammals, there's really quite a strong relationship on that scale. So, but anyway, they did different histograms show you something about that pattern. There's a bunch of data sets that are included with R that are just become standard once it's installed. Right? So if you type this, it lists a bunch of variables, different data sets that are there. Airlines data, carbon dioxide, some things from experiments, some things from surveys, and so on. There's a lot of different data sets that are there. So that's put up here. I can click back here to this thing here. One data set is called rivers. These things actually have little help files on them that tell you a little bit more about them. Many of our commands have help files in R. So if you type help of rivers, this data set describes length of major rivers in North America, 141 major rivers. And it just has the name, the links. It doesn't tell you what it is exactly. What are some big rivers in the United States? Any other? Colorado is very large. Missouri, a few others. Connecticut, it's a pretty good sized river. So the histogram of those lengths, though, in miles, right, also is really skewed. There's a few, 4,000, 3,000, right? That's going pretty far across the United States. Right? Others, the major ones, are not nearly as big. But on a log scale, it looks more symmetric, more bell-shaped, right? Not quite as skewed. You could do a summary, on the rivers scale. The median, the mean is quite a bit bigger than the median because of the skewness, and the distance from the first quartile to the median is a lot smaller than the median up to the third quartile because things are stretching out there. If you do a summary of the rivers on the log scale, though, then the mean and median are quite close to one another. And again, this doesn't necessarily do standard deviation on the log scale of rivers. And a lot of our observations would be on this log scale at the mean, plus or minus a couple standard deviations, sorry. So about 6.176 plus or minus 0.59, another 0.59 is going to take up a lot of the area. Yes?
How do you get, like, like my data is like going into the top left, like it's not looking like that. That's just like showing me data in like a chart form.
Which one? So,
And this is like for the brains, like,
oh, the brains up there. So the, if you click, right, so on this environment up here, so I made this one smaller, right? This brain, so if you do this little arrow, it opens up this little description here. If you click on this, it opens up a little spreadsheet up there to show you.
okay. So then how do you just like get it the way you had it before?
If you want to get out of this, just click on that. You can close each of these individual windows. If we're not using this homework one, I'll close that. That was my last class. We're looking at this one. So you can close any of these. Here's this list of our data sets. If I don't want that, I can close that one. And then if you click carefully, you can also make that one bigger to see these things that are there. So the rivers are there and so on. You kind of toggle for those. One data set in there, just as a time series example to show you a different one, concerns CO2. So, and this must be a typo. That can't be a 0, that's an O. Right. So one data set has measurements of atmospheric CO2 taken in Hawaii, right, at the Mauna Loa observation station. So there's atmospheric concentrations, part per million, and a little bit more information there. Slide through. Often these things, tells a little bit more. The time series, 468 observations, 1959 to 1997. Little detail there. A source from where this came from, and a few other references. So sometimes those help files for some things that we have will be useful. Time series is something that there's a plot option, right? So these are the plot of the CO2 values at Mauna Loa over time. And last time I mentioned that often there's more going on with time series than just the mean and standard deviation. We can do the mean and standard deviation, like the mean CO2 value, CO2, right? And the standard deviation of CO2, right? So 337 is here an average across that, about 337. And 2 times the standard deviation is about 30, right? So 337 up to 367, 337 down to 307. The mean plus or minus a couple standard deviations covers most of the range, but that's a whole story going on here. How would you describe the pattern over time?
It increases.
Yeah, there's a pretty definite straight increase over time, right? But there's a little wiggle in there. Any explanation for why there's this wiggle?
Like seasons?
Yeah, seasons, right? As summer comes, the trees grow and bring in and take in carbon dioxide. As they die in the northern hemisphere, right, they expel carbon dioxide as they decay, and so there's this seasonal, right? Well, is it possible that the trend is all due to the seasons? No, I mean there's this bigger trend that's even much bigger than the seasons by several factors of size. Anyway, that's in there. Another data set that's in there is about the states in 1977. And it happens to be in R as something called a matrix. And so it's a little easier to deal with things if there's something called a data frame. That's a little technical detail that you don't need to worry about. But these is information on the states. So help is available since it's a R data set in there. And so these are facts and figures about the 50 United States. Right? And this particular one has all 50 rows, so all 50 states. So state.xs, I would say the first 3 rows, if I want to see that. Alabama, Alaska, Arizona, etc. And then it has different data. Right? population, income, illiteracy, life expectancy, murder rate, high school graduation rate, area of the states. Frost is the number of days January temperature below freezing. Are you interested in looking at any of these variables? Curious about any distributions of anything? Yeah.
Look at the murder one.
The murder one. How do you want to summarize murder?
Maybe like, just like a summary, I guess.
It's a summary of those. If you just type summary of, have I attached it? I don't know if I've attached it. I'm going to see if I've attached it. Yeah, I have attached that ST there. So I can just do a summary of murder. And what was it? Murder, they're capitalized, so MUR. Murder. So there's murder, non-negligent manslaughter per 100,000 in 1976. Ranging 1.4 up to 15. All right, murder. So this is kind of the distribution. Are you interested in any particular state?
Let's do Vermont.
Do Vermont.
Yeah.
Right. So let's see, how can we do that? So how can I find let's look at the first 3 rows for the state. State. To reference Vermont. Well, I'm just going to do, let's just do you're going to have the states, well, it just gives the numbers. State, and so we want the row names as a command of state. Is that equal to Vermont? And that little comma there is there's 2 dimensions. There's rows and columns. So here's Vermont. All right, so murder rate 5.5 out of 100,000. So kind of in the lower third, right? But not the lowest, not the highest. Which ones have murder less than 1? Okay. Oops, nothing's less than 1. Less than 2. North Dakota and South Dakota. Very low murder manslaughter rates. What's the highest? So it looks like, say 14.5, I'm just guessing, right? Alabama, or greater than 14, Alabama, 5, Georgia. So, your regional. What do you think a box plot for the murder rate would look like? Is it going to be really stretched out with a bunch of outliers way high or way low, or a little bit more symmetric and balanced, right? So, well, there it goes. Not too interesting. But, quite symmetric, median, first quartile, third quartile, not really pretty good actually. You can put labels on these things, murder rate. You can put that on there. You can put different ways of putting on murder rate for 50 states. Put little captions on there, manipulate things. Do you think any of these variables are going to be related to one another? Right. Well, let's look at one. What variable do you think is going to be really skewed? Which of these things is really different across the states? Population. Population. Histogram of population. Okay. There's some very big states. Which ones? Right. Which ones are the biggest states? Yeah. Which? Sorry.
New York.
New York in terms of population.
California.
California. Right. So if we do these states, and maybe the population is greater than those are in thousands, they must be in thousands, right? So 15,000, thousands is 15 million. California and New York are the biggest two. Which are the smallest? Right, less than, I don't know, what's that? Let's do, just sort this to see what the lowest values are, right? These are the lowest, so 365,000, 376,000, and so state with populations less than, say, 600,000. Alaska, Delaware, Nevada, Vermont, there we are. Vermont's even up over 600,000 now, so this is since the 1970s, so it's grown significantly, but it's still pretty small in there, right? You could do some different variables, right? How would we calculate population density? Yeah.
Total it's total population over state size.
Yeah, so population over land area, which is called area here, right? Should give us a density. So now we have a new variable. We can look at density. So there's some that are, I guess, 1 person per square mile, and others that are much, much less, right? So anyway, right, and so how would you get that? You can do a little manipulation to find the one. So let's say we want to do things in order of density. So these are just little tricks. You wouldn't necessarily have to know all these things, right? So let's just do the area and population. And this will give the ones that have the lowest density. So Alaska, Wyoming, Montana, Nevada have the lowest density on there. Others like New Jersey, Rhode Island, Massachusetts have the highest density. So you can learn things about those. The density is pretty skewed with a bunch of them having smaller densities and so on. So, do you think any of these variables are related to one another? ST, here are some of these, I guess this is bigger, right? So population, income, literacy, life expectancy, crossed. Do you think any of these are strongly related to one another?
Literacy and high school graduation.
Yeah, so we could do a plot, say, of literacy in high school, S dot graduation. So it's somewhat related, right? As you get as this one's bigger, literacy is smaller. It's noisy, but there's a trend in the direction you might think. It's a more literacy with lower high school graduation things. Maybe you would want to do a plot of, the other way. So it's 65%. Now this is 1976, so things might be a little bit different. And there's lower illiteracy, 0.5 to 1%, and then lower high school graduation rate, more illiteracy. So, right, so you can use the descriptive statistics to explore. So it sounds like installing the R and starting through some of the work has worked for some people, but some are still having some troubles. The Mac seems to have this extra bit of this X11 program that might or might not be needed depending on which version you're using. In the Macs, it looks like there's some versions of R for different operating systems, 10.11, 10.10 or whatever. Check that you're using the one that corresponds to that and see how it goes. And then, just communicate with me as it's going along. If it's having problems, and you can bring your computer in, we can try and do something with that. If anybody does it one way and it doesn't work, but they find out they do something slightly differently and it's a little twist or some little thing that makes it work better, I can share that with everybody if you let me know. For the short term, in terms of doing the homework, through the labs or the library, that's there. If you have a friend in the class where it's working on their computer but not on yours, and you can sit together and go through the questions, you know, you can do that just to help out. And then, you know, everybody can write up their own solutions to that. But, you know, you can try to help each other through that at the beginning of this. And if we can get things worked out, then hopefully it'll be smooth sailing down the road. All right. Thank you. Yep. So you tried it and it didn't work so well?
I have it on.
Uh-huh.
I don't know. But she can't find it.
I had to re-download our studio
Okay.
again.
They didn't save it on there or something. So, you know, if it went into downloads, you might look in your download folder and it might have that exe file, the executable file might be in there. And then you can click on that executable file and it will go and reinstall. So it might be hidden in there in your downloads
Okay.
if you do it, so.
I just have a question about this.
Yeah.
So like, I got the cholesterol one open. How
Yeah.
do I just like run these commands? 'Cause
Okay, so cholesterol, so it's called cholesterol in here. I had called it CHOL as a shorter
okay.
version. So,
So could I just like change this to cholesterol?
yeah, or just the CHOL, or you could redefine, you know, you could save it as a shorter version. So a quicker way, so
Oh, just say
type
this.
CHOL, look,
Alright.
it's in R as this cholesterol
Okay.
name. CHOL, and then do the little backwards arrow thing.
this
So
one?
that one, yeah, and the shift, and a minus right in there. And now type out the capital CHOL, cholesterol.
Okay.
That, yep,
So that
and then
right
tab it, yeah, or click it, yep, and do that. So what this has done is
Okay.
copied
Yeah.
your long name into a version with a short name. So if you use the one with a short name, and now run it,
Okay, thank you.
Yeah.
So I was just like trying to figure out why that wasn't working the whole time.
yeah, it was looking for that specific name and didn't figure out that you had a longer name for it, so.
Thank you. That's really
Sure.
helpful.
Good, all right.
Have a good day.
You too.